Good morning. We are at our third day of online work. Today is Wednesday, April 1. Happy April. And we're continuing on working with IXL skills, which are online. And we're going to be covering skills B2 and B3. And just so you are better familiar with how we come up with these numbers, what this means, IX skills B2 and B3, is that if you were to go to the IXL website, click on Learning, and then a box or drop down opens and you scroll all the way down to where it says G for geometry. You would click on that and that would bring you to the skills section, and you will see over on the far right hand side a box that lists the total number of skills. Click on that box and the skills will pop up and you'll see a page that has all of them there. You will go to subsection B, as in boy, and you will complete skill numbers 2 and 3. So this is skill number 2 in the first bullet, and the second bullet is skill number 3. So skill number 2, you will solve for the length of a line segment on a number line and demonstrate which property is used for each step of the solution. And for skill number 3, you will use the additive property of length to determine the combined line of 2 line segments. Okay, so because this is an online course, again, it becomes extremely important that you use paper, and I'm showing you here again the whiteboard that I created out of plastic sheeting, and in this case there's inside of it a graph grid, but you can see it's similar to the pages that I've been using in my book that I keep my lessons in. So you have that that you can easily create and use if you wish, because you can again erase what you put on it so long as you use some form of Expo, let's turn this around, Expo dry erase marker, and that works perfectly on these, and then you can erase them. If you do not want to use the grid, you can always put a blank sheet or even line paper on it or into it. I do have just a plain sheet of line paper to demonstrate. You could use that too, just all by itself without the plastic sheeting. You'll just be writing your notes out. But whatever you do, make sure you write this stuff down, because if you don't and you're guessing it, you are never going to get to the 85 score that you need to show mastery and also to get your extra credit that I mentioned in my email yesterday, and will mention again in my email that you'll be seeing today. Now we're going to go over to example 1, and so this is an example that has to do with the very first IXL skill. So that's skill B2, solving for the length of a line segment on a number line. So here you see a number line, and it wants to know what the length of CD is. So if you look at your number line here, you can see it has numbers, and you can see you have C and D. Now, what a lot of people forget is that a number line is actually the x-axis. Any horizontal number line like this is considered the x-axis on an xy coordinate chart. So these points would be x-coordinates. Okay? So for C here, we could label C as our first x-coordinate. We could call that x1 or x sub 1. And then the D would be our second x-coordinate, so that would be x sub 2. All right, so let me just get my papers back in order. All right, so what we're going to do here is we're going to use basically absolute value to determine what the distance is between these 2 points. People who are dealing with number lines a lot of times have trouble coming up with exactly how how many units there are between 2 points. So I'm going to show you the way you do it, and that is by using absolute value equations and expressions. So we're going to create an absolute value equation. And so we've got this length CD, and we want to know what its length is, so CD has to equal something. So I'm going to put down here CD equals, and then what it is, it's the difference between the x2 coordinate and the x1 coordinate. And so when you talk about difference, you're subtracting, and so you're going to subtract the x1 coordinate from the x2 coordinate. So here's your x sub 2 coordinate, and you're going to subtract the x sub 1 coordinate. Now the thing is that you could be a negative land on your in your x number line here, and in that case these numbers could come out negative, and we need to account for that by setting this up as an absolute value equation. So I've set up the absolute value brackets, and if you remember, what happens with absolute value is that if you get once you combine these two coordinates, if you get a negative number, it has to come out as positive, because in geometry land you do not have a negative measurement. It doesn't exist. All right. So since we now know what x1 and x2 is, we're just going to go ahead and we are going to simplify this. So CD is going to equal the absolute value, and then we're going to insert our x2, and our x2 over here is actually 9. And our x1 coordinate over here is actually 6. So C and D, 9 minus 6. All right, so now you just simply subtract 9 from 6, and you get that CD equals the absolute value of 3. And then now, again, because geometry says you cannot have negative numbers, now this doesn't have to be negative, any number that comes out has to be positive. This already is positive. So you just simply rewrite this as CD, or the measure of CD, equals 3. Now some of you might be asking, why didn't I put a little line over CD? Because we're used to seeing this like that. And the reason is because we are using equal signs here. So this is algebraic measurement. So you have to remember that when we are dealing with the addition postulate, or the addition rule, we have to convert over to algebra, and so these would be considered just, this could be the measure of CD, the measure of CD, and so on. Okay? All right, so that's our first example. And so now let's take a look at another example. This is going to work exactly the same way. So again, this is our x-axis. We're going to use absolute value. We want to know what the length of HK is. All right, so we're going to write again HK this time equals the absolute value, and we're going to make, again, H is going to be our x sub 1, K is going to be our x sub 2. So remember, we're doing x sub 2 minus x sub 1. Subtraction is always backwards like that. So having said that, then we're going to x sub 2 is 2, so we're going to do the absolute value of 2 minus, and then we've got negative 1 here. So to deal with that, we've got to put it in parentheses. And it actually is always good practice whenever you are substituting in values for a variable like this, that you always put it in, in parentheses. So we could put the 2 in parentheses as well. Okay. All right. So this then would equal. Now a negative negative 1 is a positive 1. So we have, when we simplify this, we have the absolute value of 2 plus 1. And of course, that is, again, the absolute value of 3. Okay? So now you've seen two different lengths. I shouldn't say that the lengths were different. The lengths ended up being actually the same, but in two different parts of the number line. One used just positive numbers. That was the previous page we had. And then this one, you'll notice you had some negative numbers involved. So it works out the same, though, with absolute value. You're always, even though you've got negative numbers over here, you always are going to end up with a positive answer. All right? Okay, so let's go on to, let's see here. Let's go on to example 2. I think we took care of that. Yeah. All right, and so example 2 is, let me just go back and double check, make sure I didn't skip a page here. I think I got everything. Let's see. Yeah. All right, so example 2, we're finding the combined length of two line segments. And so in this case, we've got line segment. We've got to be careful about this. Let's look at what this says. It says AB equals 22, BC equals 4. What is AC? So you have to think about this, and when you put together your number line here, or in this case just a line, because it's a line segment, we aren't going to do a number line. B is attached to BC, and that makes AC. So that means that we've got a line here that goes from A to C. And here's one part of it, AB, and here's the other part of it, BC. All right. So let's look at the value for AB. It's 22 units. So we're going to put a 22 over here. And then BC is 4 units. Now it becomes a little clearer. All right, so we're going to set this up again as an equation. So in this case, AC, the whole thing, is going to equal AB, the first part, plus BC. Okay? So that's considered the additive property. Of length. All right? Okay, because of course, again, we have to support this. All right, so now we're going to substitute 22 for AB and 4 for BC. So 22 plus 4. And of course, 22 plus 4 is 26. So the length of AC, so what we've done here is we're going to add, we added. So we're adding 22 to 4, and then we have the total, and the total is AC equals 26, which is your answer. Okay, so you've got your algebra explaining this. So many of you, when you do these things, you eyeball them and you just write down an answer. I don't want you to do that because, frankly, you're going to have to go into some really sophisticated stuff as we go along through this IXL. And you got to follow this process, because if you do, then you'll be able to handle the more difficult stuff. Okay? All right. So I've got one more to show you. And this again is an example about adding together two line segments to create a longer line segment. So in this case, equals 12 and GH equals 7. What is the length of HI? All right, so GI, let's find it. Well, GI, oh, it's the whole bloomin' thing. So what we need to do here is just show that for the whole darn thing, it's 12 units. And then that says GH, that's this part here, is 7. So HI, we don't know what it is. Question. All right. So what are we going to do? Well, same thing we did before. We're going to set up an equation. The whole thing is GI. So GI equals GH plus HI. Again, additive property of length. Okay. All right. And so now we're going to go ahead and substitute 7 for GH and 12 for GI. So 7 for GH and 12 for GI. All right. So GH is 7, let's write that over here, and GI is 12. We don't know what HI is, so we just have to leave it in there. Okay, so what do we have to do then? We have to solve for HI. And to do that, you got to undo. Right? All right, so that means we're going to subtract. We want to subtract 7 from both sides to get HI by itself. So subtract HI. I'm sorry, subtract 7 from both sides. So I subtract 7 over here and 7 over here. And 12 minus 7, let's see, we could use our fingers. 8, 9, 7, 8, 9, 10, 11, 12. Aha, 5 fingers. We can see those. There we are, 5 fingers. So we got 5 equals HI. All right. So that's our answer. 5 equals HI. Now, some of you again are going to say, oh, this is just, a lot of work to do and I can figure it out in my head. Again, this will get more and more complex. So if you follow this and make sure you are showing your steps, you will know what you're doing and you will not get lost. Okay? All right. So that's basically it. Let me just go back and pull up our first sheet here. So you know that you're going to go to back to IXL and you're going to complete again in section B numbers 2 and 3, and you need at least an 85 in each skill section. To get extra credit. Okay, so that is it. All right. We will see you tomorrow, and thank you very much. Take care. Bye-bye now.